Okay, so we have been going along in a great pace. So we have looked at how we can import data, inspect data, visualize certain features of a data, understand what have higher significance to the target value or the target feature that we are looking to estimate, and some correlation factors with uh, graphs being plotted, and data cleaning was another factor that we looked into, and slowly we moved on to one hot encoding and ordinal encoding, and recently we also looked at custom transformers and feature scaling. So these were quite a few set of learnings that we came across in past few videos. Now we have reached at a critical junction where we can build a build a model, train it better, tune it better, and evaluate this model better. So get ready for today's learning. It's day 16. So in this session, we are going to be looking at a small data set where we have size, bedroom, age, and price, right? So yeah, this is a very simple data set. So price is a target feature that we want to analyze. So we are splitting here with test and train data set, and also we are having to create different models with different methods like linear regression model and a decision tree model and a random forest regressor model, right? The one way to measure all of these models is mean squared error or RMSE. Both are the same, but see that root mean squared error has a value which is close to the target, right? So that way we are easy to analyze. It's easy to analyze which model has better performance. In other words, we can say that whichever has a lower root mean squared error, that's performing much better. So that's simple uh, thing where we are having this sklearn and we put all these modules and quickly train them up. So no issues for us or nothing for us to think about in this. So next few things are with respect to tuning a model or identifying which uh, parameters or what would be the best way to train a model or improve a model's training data, or which segment of the data is having to uh, make the model perform bad, right? So those are keen things that we can observe in each machine learning problem that we solve. But just take these practices as a standard set of things that you can apply to in any of the machine learning project, but you might want to be creative at each instance, looking at specific data and the kind of problem that you're looking to solve. Okay, so k-fold cross validation technique, it's a technique where you divide your dataset into equal parts or k-folds, and you train them or uh, train them with all these several parts, and you get a cross validation score with respect to the specific model that you are asked to train with, right? So in this case you see a cross validation of 5 number, indicating there are 5 parts to dataset and there might be 5 different ways of splits to a specific dataset, and that data would be split randomly, like uh, into 5 parts, and then they would be used to train and test accordingly with this cross validation method. And we are able to see these different 5 uh, values showing different mean squared error, and you could see sometimes the model performs better at a specific fold and a slightly okay kind of score, where in random forest it was at 9, and the lowest that you see um, and the lowest that a standard deviation of 34 is what you see. So as I told you, this is about testing the dataset by splitting the data into multiple parts. Why this helps? It is more reliable where we split the data and uh, help us calculate an average of all the different folds. We can even have a number of folds here, right? It is not just about taking a good data or bad data. We might need to accept that the fact that model still needs to grow, learn, and evaluate. It's a continuous learning process with machine learning models. We are required to uh, evaluate it both with good and bad data, like we always say, right? So next is grid search. So grid search helps us fine tune a specific parameter or help us evaluate with multiple parameters, right? So all the uh, so it is like a grid, and we estimate it across all the parameters. For example, here we have random forest and random states of 42. This is a usual uh, n- parameter that we see in all of the grid search CV, and estimators and max depth, and we are also specifying cross validation and a negative mean squared error. Ignore the negative mean squared error. So what this does is it evaluates the model based on all the different features of x stating uh, here we have size, bedroom, and age. So it evaluates across all of these uh, specific features, and it gives us a maximum depth and an n estimators with all the combinations in a matrix kind of evaluation technique. And it shows what is the best parameter or which is the best parameter to uh, tune the specific model with a specific set of features, right? This can help us identify which has direct correlation or specific features that help in improving the model's performance better. Randomized search uh, is similar to grid search, while we take combinations in a randomized format, like between 2 and 10, any format, and an iteration of 10 times, and you see the same random state value here as well, right? It's similar to grid search but in a more randomized format, which makes the output a lot more uh, a machine learning standard format where we are not guessing the things with a predefined set of grid kind of formation, right? So that's one thing with randomized search. Slightly optimized to grid search is randomized search. Okay, next is ensemble learning. Ensemble learning is a combination of all the models. And this would pick out the best performing model and reduce any overfitting and underfitting, thereby improving the model's performance. So this is again a method that is really used across machine learning algorithms, right? So these were few things that I wanted to touch upon in this session. So do post your thoughts or any specific things that you have used in your machine learning projects. In the next upcoming project, we are going to be looking at a specific uh, topic or similar to an end-to-end machine learning project that we did with house price prediction. We are also going to do a similar kind of project just to keep this learning going on, right? The summary or key takeaways from this lessons is something that I've written here, but just to quickly summarize, we have three different uh, methods that we can build a model with: random forest, linear regression, and decision tree. Random forest is obviously the best one, where decision tree is slightly less compared to random forest, but much better performing model than the linear regression. So, and there are techniques like we can evaluate the models with RMSE, root mean squared, and we have cross validation technique to uh, improve the model's testing behavior with splitting our data into equal parts, and then we have grid search where we uh, put all the features into a grid kind of matrix and then uh, put a combination to all of them, while randomized search is a random way of evaluating the model. So that's one thing with randomized search and grid search. And finally we had assembly learning, which is combination of multiple models to help increase the accuracy of the model that we prepare. We could also save the model, and that's one thing that you could take it as an assignment or look at the next project learning video to know how we can save a model and reuse it at different points of time. So hope you are enjoying this video learning. Do check my next set of videos where we are going to be talking about uh, another machine learning project, which is a second project in our learning. Hope you are enjoying this series. Please do like and subscribe to my channel. Thank you.